You've turned text into points in space. Now the brutal question, how do you search 10 million of them fast? A small demo cheats. Load every vector into a NumPy array. Compare the query against all of them. Done. That's brute force. Over 5,000 vectors, it's instant. You'd never notice. But scale it to 10 million on every single query and it collapses. 10 million comparisons to answer one question. Here's the honest threshold most people skip: under about 100,000 vectors. You don't need a database at all. Brute force cosine over 100,000 vectors runs in milliseconds. Ship the array. Keep it simple. You graduate when you hit millions of vectors. Need sub-second latency, persistence, filters, or many services querying at once. When you do graduate, you need a smarter index, one that finds the nearest neighbors without ever scanning most of the data. The star of the show is called HNSW, and the idea is the one your sat-nav already uses. To cross a country, you don't drive every local street. You take the motorway, exit near your destination, then navigate the small roads. HNSW builds exactly those layers on top of your vectors. The bottom layer holds every point wired to its nearest neighbors. Then each vector flips a biased coin. Most stay at the bottom, a few get promoted up. Far fewer reach the top. So the top layer is sparse with long links. That's the motorway. The bottom is dense, short links. Those are the side streets. A search enters at the very top node and greedily hops toward whatever's closest to the query. When no neighbor gets it closer, it drops down a layer. Same spot, but now finer roads, more choices. Big jumps up top, careful little steps at the bottom. A few dozen hops replace 10 million comparisons. Now approximate sounds scary, like it's lossy. It isn't. Well-tuned, HNSW returns the right answer 95 to 99% of the time. 2 dials trade recall for speed, M, the links per node, and EF, how many candidates the search keeps in flight. Tune them only once you have real traffic. There's also a cousin called IVF, which clusters vectors into cells up front and searches only the few nearest cells. And here's why HNSW scales to billions. Double your data and search time barely moves. It grows logarithmically, just a few extra hops. But raw nearest neighbor isn't enough for real apps. You need closest vectors among documents this user is allowed to see, written after 2024. That's a metadata filter riding alongside the vector search. Every database worth using supports it. Always store the org, the user, the date. So which database? Honestly, the boring answer usually wins. Most teams should just start with pgvector. You probably already run Postgres. pgvector adds vector types and an HNSW index to it. Your joins, backups, transactions all still work. Move to a dedicated system later, when you genuinely hit 100 million vectors with strict latency budgets. One trap to burn into memory. If you ever switch embedding models, you must re-embed every stored vector. Mix 1536 dimensions from one model with 1024 from another in the same index and you get silently wrong results. No error, just garbage. Underneath all of it, the API is universal. Insert ID, vector, metadata, query by vector, top K filter. The engine varies, the shape never does.